Good morning, students. Today I will continue from the ray optics. Okay. So in the previous classes or in the previous videos, I think you will get the informations about what is light, what is the reflection and reflection in the plane mirror, as well as reflection in the spherical mirror. Also, for the spherical mirror, what is the basic definitions, that is pole, focus, focal length, all these things you have already known. And the next thing is that according to the position of the object, what will be the image of that object, the position of that image and the characteristics of that image, all these things I think you have already done. Okay. So today I will start from the basic things, that is the sign conversion as well as the linear magnification in terms of the differentiation. Okay. So let us continue. So first thing is that sign conversion. Sign conversion is that, suppose if it is considered the principal axis and if this is the mirror. Okay. If this is the ray of incidence, so it will be plus, it will be minus. According to the principal axis, this is the mirror basically, and according to the principal axis, this will be plus and this will be minus. So why this sign convention is required? For the numericals only. Okay. For already we know that the mirror equation is that 1 by V plus 1 by U, that is equal to 1 by F, where F is basically the focal length, right? So where is V, where is U, and according to this where is F? So for this part we need this sign conversion. Suppose if an object is placed here, so the image object distance will be negative. Suppose it gives the virtual image, then the image will be in this. So therefore V will be negative. And if the object, if it is the concave lens, then the focal length also negative, and if it becomes convex, then the focal length will be positive. So for these purposes, this sign convention is pretty much required. Okay. Hopefully it is clear to all. Next thing is that all the distance which we are measuring for doing this numerical, we need to measure all these things from the pole. So this is basically pole. If it is here object is there, so the distance, the U will be this. If the image is here, so the V will be this. So from the pole all the images should be calculated. Okay. And when we are measuring the distance measured in the direction of incidence ray are taken as positive, while in the direction opposite to the incidence ray are taken negative. So suppose if I considering that the incident ray is coming in this way, so it will be the positive direction. But if the image is returning in this way, incident ray is reflected ray is returning in this way, it is considered as negative. Hopefully this is clear to all. Next thing is that for the concave mirror, location of image, location of the object and magnification. In this, characteristics is pretty much important. So I am going for the first concave mirror. Later on I will continue with the convex mirror. Okay. So for the concave mirror, suppose an object is an infinity. So the rays is coming like this. Reflected ray will be like this. So they are meeting at a particular point. And what is this point? This point is basically our focus. Okay. So when the object is as infinity, that is U is basically my infinity, then the image will formed at F, that is at the focus. Okay. So whatever the image size there, as it is concentrated as a point, so the image size is basically, that is diminished. You can't get the original image size. That's why the first characteristics of the object is that it will be diminished in nature. Okay. Next thing is that as the rays are meeting to a particular point, that's why the image is real, as well as it is considered as inverted. So these are the three characteristics of the image if the object is placed at the infinity. Hopefully it is clear. This is the first case. Next case. Suppose away from the center of curvature. Suppose this is my F, this is my C. Object is placed here. So, if the object is placed behind the center of curvature, please be careful about this. I am, okay, well, later on I will continue inference. So, this one, if through center of curvature it is coming, it will pass through the center of curvature as well. The image will be placed here. So, if this is A and this is B, this will be B dashed, this will be A dashed. So, as the object is placed behind the center of curvature, the image will form in between center of curvature and focus here. Okay. Later on, after completing this, I will show you, or I will tell you a trick, so you can easily remember this thing. Okay. So, as it is in the between center of curvature, and you can easily visible to you that this is AB and this is the size of A dash B dash, that is the image size. So, this size and this size is basically compared to the object size, the image size is smaller. Okay. That's why the image size will be smaller, first point. Second will be real, and as well third will be inverted. So, this is the second condition. If the object is placed just in back of the center of curvature, then the image will form in between the center of curvature and focus. Second point is that it will be diminished in size or smaller in size compared to the object. Third is real, fourth will be inverted. So, these are the four characteristics for the image. This is the second case. Third case. Considering the third case. At the third case, if I consider that the object is at the center of curvature. Okay. So, if the object is at the center of curvature, this is suppose my focus. So, if an object is placed at the center of curvature, the image also formed at the center of curvature. So, if it is AB, so it will be A dashed. So, whatever the image object size, the same is the image size. It is real as well as inverted. So, this is the characteristics of the image if the object is placed at the center of curvature. So, this is the third case. Going for the fourth case. If the object is placed in between the center of curvature and focus. Okay. particular point here. Okay. So by seeing this, what you can conclude? You can conclude that if the object is placed in between the center of curvature and focus, the image will be formed behind the center of curvature. That is, here it is drawn. So I am increasing this. Okay, as here it has midden. That's why I am doing the image here. Okay. So therefore, as the image is behind the center of curvature, and the image is obviously longer than the object, right? So therefore, it will be real inverted but longer or larger in the size. Okay, hopefully it is clear to you. Next, coming to the condition, that is if the object is placed at the focus. Suppose at focus the object is there. Suppose this is center of curvature. Where it meets we don't know basically. So if object is at focus, the image will form at infinity and it will be also magnified as well as real inverted. And the last case and most important case is that if the object is placed in between the focus and pole. So if I extended it here, the image will be formed backside of the mirror. Okay. So therefore, as the image is forming backside of the mirror, so it is basically the virtual image as well as it is magnified and also erect. Okay. So this is the cases for the, this is focused for the concave mirror. Hopefully it is clear to all. In the next video, I will continue with the convex mirror part as well as the magnification in the form of differential equation. Okay. Thank you.